So these are the weights and the values of items, and this is the capacity of knapsack. So this is the given information. Now let's create a function def get max value. In this function, let's pass this weight array, value array, and the capacity. And inside this function, we're going to create another array, items, that will hold the complete information about each item. So initially all the cells will be having value 0, and the length will be equal to the length of the weight array or the value array. So now let's fill this array. So let's take a for loop for I in range 0 length items or length weight. Let's fill items I, and here we're gonna pass an object of item class. We haven't created this class yet, so let's create this class item, and def init. This will take weight of the item, the value of the item, and the index of that item. So self.weight equals to given weight, self.value equals to value, and self.index is equal to the given index. And now self.cost, which we're gonna calculate here, cost, this will be value divided by the weight, right? So this is the cost. Now we need a comparator, right? So here we will return self.cost less than other.cost. Now coming back to get max value, here we will pass the weight of the current item, value of the current item, and the index of the current item. So this item object will be constructed and we'll put it in the items array. And this is how we will put all the items in this items array. Now we need to sort these items, and we have to sort it in descending order. So let's mark it reverse true. And now we're gonna take a for loop for item present in items. So we will pick items, and as we are sorting according to the cost, so we will be having the item, the more valuable item first. So item dot weight, so this will be the weight of the current item, and current value, and item dot value. Now we need to check if this item can fit into the knapsack or not. So we will check if the capacity minus current weight is greater than or equal to 0. That means that this item can completely fit into the knapsack. So we will put this item into the knapsack. Now the new capacity will be capacity minus current weight. And here let's take a variable, let's take it here, let's say total val, and let's initialize it with 0, and here the total value will be total value plus the current value. So this is the total value that we have added into the knapsack. Else we cannot fit the complete object, complete item into the knapsack, so we have to take a fraction of it. So let's take fraction. This can be calculated by dividing capacity by current weight. Now the new total value will be total value plus this fraction multiplied by the current value. So this will be the new total value. Now the new capacity will be the current capacity minus current weight multiplied by fraction. Multiplied by fraction. And now let's put a break here because this is the end. This will be the last item. And finally, we will return the total value. We can comment this capacity calculation, this line, because we don't need to calculate the capacity, as this will be the last item we're gonna be putting inside this knapsack. So now let's invoke this function. So let's copy this and paste this and uncomment this. And now let's call get max value, and let's pass weight array, value array, and capacity. So this will return max value. Now let's print this value. Print the maximum profit possible is max value. So this is the complete implementation. Let's run this program. So run fractional knapsack and we get 240, which is the maximum profit.